For welcome to this webinar. We are talking about the Range Rover fuel system issues. This is a free GLR webinar on how to diagnose Range Rover fuel system issues. So Range Rover, we are coming down to the AJ133 and the AJ126. So we can see a whole bunch of problems in these engines regarding fuel systems. A whole lot of challenges. Mechanics are like, what's happening to this engine? Engine is not running normal. I've scanned the car. I have done everything I could. I've done everything I know. I've done everything written on the manual. And it's still throwing me on the loop too. The fault keeps coming up. The error code. This thing keeps happening. The drivability is not smooth. The ride is not okay. What's wrong with this engine? So all of us, all technicians and mechanics and everybody around the world is having issues with the fuel system in this car. So this webinar is just to simplify everything for you and give you a clear guide on how to go about these issues in this car. Okay. Firstly, the fuel system issues in this car is. Let me get the camera away. Okay, the fuel system issues in this car is basically regarding the AJ133 and 126, which you can see in the Range Rover Sports, the L494, the L405, the Vela. So Vela is fitted with the AJ126. Then the Vela SVR is the V8 variant, which is typically identical to the Range Rover SVR, the full-size Range Rover. The Discovery Sports, most Discovery Sports are fitted with the V6 engine, not the Ingenium. So we can see a whole varieties of all these engine variants in most of the Range Rover lineup. So now this is the bunch of sensor components we can see in this engine. So over here we can see the fuel injector. This is the fuel injector here. So we can see the fuel injector. So this is the fuel injector, and then this is our camshaft position sensor. This is our camshaft position sensor. So the camshaft position sensor, this is our ECU. So the camshaft position sensor tells the CAU which position the camshaft is, or which position the valve train is at a particular time, basically the intake valve. And then this ECU sends a signal, a pulse width modulation to the ground of this injector to open, and then it can spray fuel directly into the combustion chamber. And then I want to let you know that this is a direct injection engine. As you can see, is a direct injection. Then the second one is this is an overview of the engine. So you can see our engine. This is the overview of the engine. Here, this is the location. I don't know if you can see this very well. Let me change the color to red. This is the location of the injector, fuel injector. So we have 4 injectors in each bank, for the V8, and then for the V6 we have 3 injectors in each bank and 3 injector in the other bank. So here is the location of our high pressure fuel pump. So you know, one thing you have to know about these engines is that they run louder to begin with. So when you start the car, you hear a ticking sound coming out most of the times from the injectors and most of the time from the high pressure fuel pump. So over here we can see the high pressure fuel, we can see the injectors, and then over here, I don't know if you can see over here, this is basically our high pressure fuel pump. So basically there is the location of our high pressure fuel pump. So if you can see over here, this is the location of our high pressure fuel pump. I'm going to go into details on the challenges. Most of the issues you're going to have with this vehicle is probably 30% of the issues you're going to have with this vehicle is coming from this high pressure fuel pump. So let's go, but as we keep moving, I'm going to explain in details and a more clearer view of how it works basically. Now our fuel octane rating. Now your fuel octane, this is our fuel octane rating. So what matters the most for optimum performance in this engine, that's the AJ133, is our fuel octane rating. So in an ideal fuel, we have a 224 trimethyl pentane, which is an ideal fuel for a 100% octane rating. But now we can, because of some additive added to and some other things, so having a fuel rating of 87, 89 and 93 is going to give you, I think this vehicle is going to drive really well. The engine performance is going to be at its maximum. Let me just say 80 to 90% its maximum requirements from the manufacturers. So a fuel octane rating which is less than 87, let me just say from 79, 82, is not really going to give you the optimum performance for this engine. So next one, this is the overview of the AJ133 engine. This is the overview of the engine. So I want to point out something. This guy here, this little sensor here, is our fuel rail high pressure sensor. Let me just HP. This is our fuel rail high pressure sensor. Now this sensor is to monitor the pressure of the fuel going into our injectors. Now you know that the high pressure fuel pump, which is mounted at the side of our engine, which I showed you earlier on, which I'm going to still go into details, increases the pressure of the fuel going into this ray to close to more than 2000 psi. So this sensor here is what tells the ECU, okay, the fuel here is 2000 psi, okay, the fuel pump driver module, okay, I'm okay, there is enough pressure in the rail, please I don't want you to prime the fuel pump again. That is what it does. It increases the fuel output. Remember that this thing is a direct injection. For the fuel to overcome the compression power of this engine during the compression stroke, it has to inject fuel in a high pressure for the fuel to overcome the high pressure of the compression of the piston. So next we are going to look into the benefit of direct injection. Why did Land Rover, why did JLR go into direct injection? Because of some many regulations for efficiency, fuel efficiency, excellent fuel efficiency, and awesome performance, high power output over the traditional FI engines. Now, because of direct injection sprays fuel directly into the cylinder, not from the intake port, which goes to the valve. So since it sprays fuel directly into the cylinder, there is a mixture, there is a thorough mixture of the air fuel mixture. Then only combustion of air goes through the opening port, so the air does not mix with the fuel. It's just only air that goes into, and you have to remember that this is a supercharged engine, so there is an overflow of enormous air going into, so lower fuel consumption figures, and low emission. Now I may not necessarily agree with this. Actually, low fuel consumption, I may not necessarily agree with it. I'll have to do an in-depth research on it for me to tell you whether it's a low fuel consumption. But all I know is that it lowers emission level, actually, because the air fuel mixture gets to mix thoroughly with the air. And remember, this only happens in the compression stroke. It happens in the compression stroke. So direct injection does not spray fuel during the intake stroke. It is during the compression stroke. That is where direct injection sprays. That is when it's sprayed. Now, this is our fuel system low. Now, this is our fuel pressure system low. This is our fuel pressure sensor, low fuel pressure sensor. This low fuel pressure sensor, now it differs from the formal high pressure fuel sensor. This low fuel pressure sensor monitors the fuel. On your traditional engine, you have a tank and you have a fuel pump that we call it lift pump, that pumps out the fuel. When the fuel pump releases the fuel, maybe at 65 psi, when you have your low fuel pressure sensor telling the ECU the pressure of the fuel going into our fuel rail, that is when the ECU will know that, okay, this is the amount of fuel, or this is the pressure of the fuel going into the rail. Maybe at wide open throttle, the sensor will tell the ECU, okay, we have 65% psi of fuel pressure going into the high pressure fuel pump. And then the ECU will say, okay, fuel pump driver module, please, I want you to do something. There is a wide open throttle. Maybe the driver is trying to command more power. Okay, please, can you prime the fuel pump to 100%, deliver more fuel? And you see, this thing happens within a twinkle of an eye. It happens within microseconds. So this sensor, the low fuel pressure sensor, is located now on the close to the bell housing of the transmission. So close to the bell housing of the transmission. The bell housing of the transmission simply means where the transmission mounts with the engine. So you will see this sensor. This is the fuel low pressure sensor on the Sports and LR4 close to the bell housing. Then on the full size Range Rover, that's the big body, the big daddy Range Rover, not the L4, not the L405. You will see it at the driver side. When you remove the tire of the driver side, you will see it at the liner close to the exhaust once you remove the tire. And then this low fuel pressure sensor can typically make the car not to start. It can blank off totally fuel supply to the fuel rail. For instance, if you don't have fuel in the tank, when there is no fuel in your fuel tank, you drove dry tank, it will blank out fuel supply. You need to do what we call fuel pump priming. You need to prime it. So most times, even if there is fuel and you don't do the priming, fuel pump priming, the car won't start when you're on a dry tank, or when it sees an uninterrupted reading that does not synchronize with the manufacturer's reading. It blanks it off. So second one is this is our high fuel low pressure sensor. Fuel low pressure sensor. Now our output pressure is 45 bar or 65 psi, except during engine startup. At engine startup, the target pressure of the fuel delivery line is 630 kilopascal or 6.3 bar or 91.4 psi. Now, your Range Rover, if you just open the driver's door, the low fuel pump primes. What is the reason for this? To give you the maximum fuel pressure output. So when you're diagnosing this car, you are with your OBD scanner, you go to the live data, open the driver door. If you see anything less than this figure, if you see anything less than 4.5 bar or 65 psi, there is an issue, first of all, with your fuel pump in the vehicle. Secondly, if you have another good known sensor, first of all, try by replacing the sensor. Then when you start up the engine, the target fuel delivery line should be around 6.3 bar or 91.4 psi. So if you see anything 91.4 psi to 95 psi or 85 psi, 85, so see, let me tell you, you might even see 70 psi and the car will run good. So anything from 85 psi, 91 psi, let me just reduce it to this lowest step. Anything from 91 psi to 95 psi, that tells you that you have a good fuel pump, or you have a good fuel low pressure sensor. But if after replacing the sensor and you keep seeing this code again, you keep seeing fuel low pressure sensor issue, replace the fuel pump. And after replacing the fuel pump and you have not replaced the fuel low pressure sensor and you keep seeing the code, replace the fuel low pressure sensor. Now, fuel pump driver module, I'm going to dwell much on this. Now, fuel pump driver module, now it sends signal to the ECM. Now let me break it down for you to understand what I mean. The pulse width modulation signal from the ECM tells the fuel pump driver module, the required pump driver module. A pulse width modulation signal from the ECM tells the fuel pump driver module. That's the meaning of FPDM. Simply means fuel pump driver module. The required speed for the fuel pump. The on time of the signal represents half of the fuel pump speed, and the signal has an on time of 50%. Now let me tell you now. You start your vehicle. A pulse width modulation signal, which is fed from, now how does the pulse width modulation signal generate? Because you have different sensors. Remember, you have our low side fuel pressure sensor, which is our fuel pressure sensor B, which the one I told you is located at the bell housing close to the transmission, and our high range fuel pressure sensor, which is located at the engine close to the injector rails. Now, all those sensors monitors the fuel pressure of the car. When you start your car in the morning, let's say a cold start, what happens? The fuel pump driver module, the ECM will tell the fuel pump driver module, hey, this guy has started this car. Please, I don't need maximum fuel pressure. Let's say the maximum fuel pressure in this car is, let me just say, 3000 psi. I don't need maximum pressure because it's not commanding any throttle response. But this is a cold start, which means at a cold start, your RPM goes to like 2000 RPM. So I need a maximum output pressure of 70% or 50% or 20%. He sends it to the fuel pump driver module. The fuel pump driver module said, okay, I have understood what you said. This is a cold start, and remember, on a cold start, it revs up to 2000 RPM. So please, fuel pump, you will send a pulse width modulation telling the fuel pump, okay, I want to command you to, let me say, 70%. It commands the fuel pump to 70%. When the car is at idle, let me just say close to 800 RPM or anything, or just when the car idles normally, it will say, okay, the car has dropped down, the idle has dropped down to 1000 RPM, and the car is idling normally. Please, I want you to cut the fuel pump driver module. I don't need too much pressure. The pressure you are feeding is too much for this driver, is too much for the car. Please cut down. Then the fuel pump driver module is, now the ECM is telling the fuel pump driver module this thing. Then the fuel pump driver module will now say, okay, fuel pump, please, I want an on time of 30% or 50%. So the fuel pump, you are going to give me pressure. You are going to give me pressure. I'm going to send an electrical signal to you that makes you turn every 10 seconds. That makes you generate pressure every 10 seconds. So give me a fuel pump pressure that is equal to the idle of I want. So when I command, when there is an open wide throttle, the ECM is still going to send signal to the fuel pump driver module. This driver wants to climb a hill, or this driver wants to go into drag race. Okay, I need a maximum fuel pressure. Then the ECM will send the signal to this guy here, the fuel pump driver module, which is this guy here. And this guy now, what this guy will do, this guy here now, and this guy will say, okay, we need maximum pressure because this guy here is going into drag race or is climbing a hill. Okay, give me the maximum pressure you can, and it will send maximum pressure. Maybe the fuel pressure is going to skyrocket to almost 3000 psi, 2.5 psi. That's the maximum pressure. That's how it does. On normal traditional cars, it does not do this thing. So this is how it does to give you better fuel efficiency and give you the smooth drivability with demand and safe fuel. So our next one is the next thing we are going to talk about. Now this is the position of our high pressure fuel pump. It is attached to the crankshaft via a chain. So it is attached to the crankshaft, and then as the crankshaft turns, it turns this lobe here, it turns this little guy here. As your crankshaft turns, it turns this little guy here. See, it is joined to a chain. As your crankshaft turns, it turns that little guy here, and this little guy has a lobe which turns your high pressure fuel pump. Now with this high pressure fuel pump, the bank 1 is what? This is our bank 1A, this is our bank 2B. That is how it is being done. So if you want to set your timing in this car, first of all, make sure that the crankshaft is at TDC. It's at its normal place. It should be required by the manufacturer. This is the picture of our high pressure fuel pump. So as you can see, this is our high pressure fuel pump. Now this is the solenoid. This solenoid, its work is to regulate the volume. That is where. So this is our inlet from our fuel pump. This inlet is from our fuel pump. This outlet goes to fuel rail. it goes to fuel ray, while this input is from our fuel pump. Now this is a solenoid. It's a solenoid driven is a Bosch type of high pressure fuel pump. This is our cam loop. Don't forget that this is our cam loop, and then this cam is connected to a chain. It's connected to a chain with our crankshaft, and then this solenoid you are seeing here is just trying to it's a volume solenoid. So what it does actually is, during the time that one injector is going to fire, it increases the volume and reduces the volume. That is what it does there. It increases the volume and reduces the volume. When the pressure increases, it has signal. The ECM sends signal to this thing to increase the volume and reduce the volume. That's typically what you see here. And then the ECM controls the output of the high pressure fuel pump to deliver the required volume of fuel pressure at pressure up to 150 bars or 2175 psi. This is our maximum pressure. Up to this, it can go. I think it can go up to 3000. Yeah, at wide open throttle psi, at wide open throttle. So depending on the command that the ECU gives. So the two high pressure fuel pump are identical, mechanically driven pump installed. So this, as you can see, is a mechanical driven pump. The rear high pressure fuel pump is identified as number 1. So if you can see, is identified as number 1. The rear is identified as number 1, while the front high pressure is identified by number 2. So this is wrong. This is wrong. So if you want to know if this is wrong, trace the fuel line. You know your bank 1 and your bank 2. So you know your bank 1 and your bank 2. So this is your bank 1. This is your bank 2. So this is an acoustic cover that covers the pump for excessive noise. It filters the noise, and then you have to be watchful with this. Now, this covers the high pressure fuel pump. This cam loop. This is like a cam cup. It's like a cam cup. You understand? The cam loop touches this. There can be an excessive wear in this, and you can have a rich condition where the fuel from this fuel injector can leak inside your engine oil, and you have a rich condition. So how do you diagnose the problem? You check your oil. Since this car does not have a traditional dipstick, what you do, you open the cap of the oil filler cap and smell the oil. If you smell raw fuel, you know that there are excessive fuel that is leaking from this high pressure fuel pump directly into your cylinder block. So what do? You change your high pressure fuel pump. That's basically what you do. So the fuel rate pressure sensor at 3.0 to 0.5 volts on a cold start. If you see something like 2.3, that means when the car has really warmed up. Anything greater than 2.3, let's say you saw 4.0 volt or 4.7 volt, is an internally shorted sensor. So you go to your live data, but I want to give you a guarantee that none of this makes sense. None of this makes, what did I say? None of this makes sense, because you can still have this reading. You can still have this stupid reading, and your car runs fine. You can still have shorted sensor of 4.0 volts to 4.7 volts. Your car still drives fine. You can still have this reading, and the sensor is still not good. So none of it can still have this reading, and the car drives fine, and you might not have this reason, and the car won't drive fine. So none of it makes sense. Let's go to the next one. So this is the location of our fuel high pressure pump. This is the location. So remember, I told you that this is bank 1 and this is bank 2. So if you want to check this thing, follow the fuel line. Anyone that the fuel rail cross pipe goes to each. Anyone, if it goes to bank 1, you know that this one goes to bank 1, then this one goes to bank 2. So inside here there is a cam loop. Inside here there's a cam loop that drives your high pressure fuel pump. So this is the location of it with the acoustic cover fitted into it. Now this is our injector. So this is the injector. So the thing there is that removing this injector most times are pain in the ass. So we have our injector removing tools. So the Teflon seals is very, very good. So we seal up this injector with Teflon seals. So you install your Teflon seal and put it to you make sure you clean the mount and the opening and the debris there, and you mount it back. So because compression can leak if it's not mounted properly. So make sure that anytime you remove this thing, anyone that is bent, it's better to remove to replace the injector. And then if you are having any code for injector in any bank, you replace the 4 injectors in that bank. So if you are having any code of a rich mixture, this injector can leak. If you are having a rich condition where your fuel trim is very high, you can, if you have a positive fuel trim, and then the injector might be dumping fuel directly into the cylinder block or the piston. So you replace the injectors in that bank. So any bank you see injector fault, you replace the injector in that bank. So the next one is our fuel pump camshaft timing. So this is our fuel pump camshaft timing. So before you can time this engine, first of all, you need the timing tools. First of all, this is our for the first one we see here. This one here is our crankshaft timing tools. Crankshaft is our crankshaft timing tools. So you turn the crankshaft to TDC, and then you lock it from the you remove the crankshaft sensor, and then you lock it to position. Before you do anything or you mess up with this car, make sure that the crankshaft is locked first. And then this is our alignment tools for the fuel pump camshaft timing. This is our alignment tools. So you make sure, I will show you where is being aligned. So this is our alignment tools. So this is for the fuel pump camshaft timing. Caution: only rotate the camshaft clockwise. That's only rotate the crankshaft clockwise. Make sure the crankshaft is fully locked. So you make sure that your crankshaft is fully locked, and you rotate the crankshaft clockwise using a suitable mark. Mark the position of the pulley as illustrated. So you can mark the position of the pulley, but all these things doesn't make sense. Just rotate the crankshaft to TDC. The keyway must be at what, 6 o'clock. If you remove your timing pulley, rotate the crankshaft so that your keyway is at 6 o'clock. Once your keyway is at 6 o'clock, install the tools there. Install the crankshaft tools there. It will lock it in position. So this this is our timing for the high pressure fuel pump. So as you can see, this timing is incorrect, because if you watch here should align a bit with here, and then here should align a bit with here. So this timing is incorrect. If you watch the second one, if you watch this one, you will see that our timing is very, very correct. And then another thing I want you to know the position of the FOMOCO. The FOMOCO is positioned on top, so you can still put your timing, high pressure fuel pump cam loop timing tools, and it fits correctly. And the position of this FOMOCO, the position of this FOMOCO is downwards. So, and that means you are 180 degree out. So you watch the position of that FOMOCO, it must be up, and you put your time. So if it matches, that means your fuel pump timing is correct and is very, very to the end of this webinar. So as you can see the position where you put your timing lobe for the fuel pressure fuel camshaft timing. So this is where you put the timing tools. So as you can see how this tools was not able to fit in correctly. So what you see here is that this is tools is not fitting correctly, so this tools now is not fitting correctly. It must be all the way inside. It must be inside. So you won't see this a bit of it is coming out. It must be all way inside. And then another thing I want you to pay attention in this engine is this guy here. This guy here has wrecked so many mechanics in Africa. This guy here. So I want you to be fully be conscious of this guy here. So be conscious of this guy here, the high pressure fuel rate sensor. If you have a range performance, if you have a fault code of fuel pressure sensor range performance, or high rail fuel pressure sensor, if you see fuel rail pressure sensor range performance, replace this guy here. That's most of the, and you have restricted performance and the engine reps, the reps in an uncontrolled manner. That's reps in an uncontrolled manner. Just know that you are having a high pressure fuel system sensor, and your high pressure sensor is faulty. And then if you started it, you just parked your car, you tried starting it, the car refused to start, or maybe you are low in fuel and then you added fuel and the car refused to start, just know that your fuel pressure, your low side fuel pressure is having issues. Or you found out that okay, I have parked this car for a while, I tried starting it refused to start, or I drove on a dry tank and I added fuel, it refused to start. You have to prime the fuel pump. That's firstly. And then if it's even okay, you change the low pressure sensor of your fuel. And then if you see excessive fuel, a rich condition, or if you notice that if you open your oil cap, it smells fuel, it smells a whole lot of fuel, know that fuel is leaking into the crankcase. So you know that most of your fuel is leaking into the crankcase. And if you hear excessive noise than normal, know that your high pressure fuel pump is on his way to hell. Is going. And if you see a high rail fuel pressure, that the fuel pressure in the car is very high rail fuel pressure, check your timing, because your timing, I think your timing is having issues. You're having issues with the timing, or maybe you changed the top gasket, or you did anything to mess with the timing, or you changed the timing chain and tensioner because they can wear out, and you are seeing high pressure fuel faults. Know that your timing is out. Or you see low pressure fuel fault, know that your timing is out. So you need the timing tools to set this timing correctly. Thank you for your time, and don't forget that this high pressure fuel rate sensor, monitor the fault code. If you see a range performance in the rail, you replace your high rail fuel pressure sensor. If you see an injector fault, you replace the whole injector in that bank. So this is a quick overview of and a recap of what we have learned so far. Thank you for your time, and feel free to share and subscribe on my YouTube channel, and I will see you soon. Thank you.